All right, quiz is over. Congratulations. If you didn't notice already, the quiz had no calculator portion. And so I figured when I was designing the quiz, I thought, let's save the calculator stuff for after the quiz. People still have some calculator questions. What type of stuff is really going to be calculator stuff on the test? So that's what I decided to do between quiz and test. So this is the kind of stuff where I'm going to have you do on the calculator. Conceptually, it's not really different than anything we did off the calculator. It's just then you can do a few more sophisticated things with the calculator, and of course you can handle really nasty numbers on the calculator. Okay, so here's this equation. It says find all this stuff. So the first thing I want to do is graph it. So in my calculator, the first thing I want to do is add a graph page. If you don't see that right away, of course if you're in here and you want to add a new document, it'll say that. Stay away from this, as we said before. Go to new document and add graph page. That's what it's going to want. So I'll go here. Okay, so what was the function? It was 3.2. Okay, I can just do this. All right. Bam! I'm going to go ahead and enter those in while we're paused. Otherwise, this video is going to get really long and really boring. Okay, so I entered that in, and if I just hit enter, what happened? Oh, let me check that out. Okay, that was weird, but I got it. I get this right away when I just type that in kind of in the default window. It's a little off the screen. If I think people seem to like this zoom out feature. Zoom out kind of down there, then I get that. Another nice feature once you see everything is the zoom box feature. You can click around, like select a rectangle you want to fill the screen. That's kind of nice because it shows this thing. Or another thing is once you have everything you like to see, if you go zoom fit, that's here. It'll usually do something you kind of like to see. If it already has, there's usually about 3 what I call landmark points on every parabola. Usually around 3. It depends on the exact parabola. But if you can see the vertex and you can see where it crosses either the x-axis or the y-axis, that's, again, sometimes 2 points, sometimes 3 points, sometimes 1 point, all there. But, you can see the point of the thing and you can see the vertex of the thing and see kind of where it sits relative to 0, 0 on the axis. That's kind of nice. So, because that's all the first questions we have here. The questions we have are things like, what are the vertex, what are the x-intercepts, that kind of stuff. So vertex, that's the first question. Vertex, as you know, is menu, analyze, minimum or maximum in parabolas. And for this particular parabola, because I've already seen it and it opens up, I want a minimum. If I select that, it's going to ask me, okay, where's the lower bound? Where do you want to start looking? Where do you want to stop looking? And then it automatically gives me a point here. And the vertex appears to be there. So let's type that in, or let's write that down. So I just stole that right off the calculator. Now, is that exactly 0.625, or is it like 0.6249732? I don't know. To get any closer algebraically, I could do some fancy algebra and I could figure that out. But for my purposes, for grading you on a question like this, on a calculated part of a test, this is good enough. All right, x-intercepts. X-intercepts would be where it crosses the x-axis. So for that we want to use what's called zeros in analyze 0, and again it wants lower and upper bound. It'll do that one, and then same thing again, menu, analyze 0, lower and upper bound, and I'll write those down. And there they are. And now if I wanted to solve for those without doing that algebraically, this is actually pretty easy. If I add a calculator page, I'm trying to find the values for which the values of x for which the function is 0. So if I just want to solve, and I think it's f1, yeah, f1 of x where it's 0 for x, it's going to give me those values. And that's a little bit more exact, and I can get more decimals on those. Look at that, if I want. So that's something you can do that easily that way. The max, min, vertex thing doesn't work as easily that way. All right, what if these had been complex? In other words, what if we were looking at a graph in which this didn't cross the axis at all and the parabola was entirely up here, and you got a question like this and it said, what are the x-intercepts? Well, if that had happened, we wouldn't have been able to do this graph technique to figure that out. We would have had to gone here and said solve it when it's 0. And on a calculator, I'm not sure that would actually work. Let me try something really quick. Yeah, I just made up a parabola here that's not going to cross the axis. If I tried to solve that, this could have been an F1 or it could have been just typed in as an equation like this. If I type in a thing like that and it turns out not to have any real roots, it's going to say false, despite whatever mode I might be in. I may have said something in class, or you might know about this. The calculator will deal with complex numbers. Like, watch this. I have it in the mode where it'll actually deal with complex numbers. Oh no, it doesn't. Oh, okay. So that's the message you get if your calculator is not ready to deal with complex numbers. It'll say put it in rectangular or polar mode, which is not bad. Doc 7.2. Change real or complex to rectangular. And then let's try this again. That'll at least give you the I symbol. Now if I tried to solve that, again, it's not going to give me any answers. So that right there, that just tells you, well, I know that this does not cross the x-axis. It doesn't have any real answers. They have to be complex. But at that point, you're going to have to go, you're going to have to go through the trouble of doing that sort of algebraically by hand. The calculator won't give you, it won't solve this for complex answers no matter what. Okay, next thing, y-intercept. Y-intercept on the graph is not too hard to find. It's kind of right around this area. Where exactly are we looking there? It's hard to kind of make the calculator tell you that. It's easier if I just do this. Tell me where f1 of 0 is. If I put 0 in for the function, what do I get? Oh, I get -8. Does it look like -8 in the graph? Well, it's hard to tell with these tick marks. I can kind of do this. I can kind of zoom in. Zoom in. Is this really going to be -8? I can zoom in a couple times. Hopefully that's -8. Like, I don't know what these tick marks are. Another way to tell it was probably -8 is looking at this equation. This is in standard form, so guess what the intercept should be? If x is 0, the function ought to have a value of -8. I don't like this zoom right now, so guess what? I can go Control Z, Control Z, Control Z, Control Z. It'll take me back to where I was. All right, so -8 is the place where that intercept is. That's easy. Okay, and then domain. Let's look at the graph again. Domain. Now there's no context on this. This isn't a word problem or anything. This is just a quadratic equation here. This blue thing. It has no real life meaning. We're not supposed to put any kind of stipulation from context on there. So x could be anything. There's no x algebraically that's going to break this machine. So the domain could be anything. The range is where it gets interesting. The range, of course, is all the possible y values, and this point here gives me the lowest point on the parabola, so it's the lowest y value, which is this, and then everything above that is possible. Everywhere else on the parabola is higher, and it'll go up to infinity, so let me put that in. Okay, so that's how I would say those things. Okay, same graph. Compute, what is the value if x is -1.5? We can just go back to the calculator page. We can just ask it, just like I did here. I can just ask that and change this to 1.5. It's going to be 5.2. And I believe it's going to be 5.2. It would show me more decimals if it was going to be more than that. So that's simply 5.2. Another way to show, like to find a value on the function of what it is, you can go back to here and you can do the table, Control T, and you go to table, and I can figure out what it is at 1.5. If I change the table settings to, instead of stepping up by 1 each time, instead of going 1, 2, 3, I can have it go 0, 0.5, 1, 1.5, all that kind of stuff. So I can actually have it tell me right there that it's 1.5. If that's the x, this is the y. Okay, next question is, at what point is the value of, oh, that's not good. Sorry about that. At what point is the value of the function 30? You could go back to here and tell me, solve this for when the, for this, actually, for when is the value 30? It'll just tell me, and it's 2 places. That shouldn't surprise me. When is the value of the function 30? So let's get out of this table. We don't want the table. I hit Control T, by the way. At what point do we get, so 30 is kind of up here somewhere. This is 35.2. So there's probably a point out here and a point out here where we're going to get 30. Let me zoom out once. So I can see 30 better. So at some point around 30, there's going to be a point back here and a point over here where it's going to be 30. I could either do it in the calculator, and I could say, tell me where that is. Solve f of x when f of x equals 30 for x. Or in the graph, you can actually graph. This is kind of an interesting way to do it. You can graph f of x equals 30, or like y equals 30. You're going to get a horizontal line, and I just need to find out where are these intersection points. And I think you've done this before. Intersect between here and here, and do another intersection, analyze intersection between here and here. And since there's only 2 functions in my graph, it's it's happy enough to know which functions I'm talking about. Anyway, negative 4.13 and positive 2.88, and that's it. I kind of like these better. These are a little nicer. Because those are the values, they have more decimals in there, and they're sort of a little more exact. It's kind of nice. You can do it either way. I'll take it either way on the test. Graph the line this on the same set of axes. Okay, let's do that. So to do that, I go back to the same graph. I want to go Tab or Control G and get back to here, and I want to graph, on the same set of axes, I want to graph this line, half x plus 3. Okay, and I do that, and I get this crazy line down here, and it wants to know where the intersection points are. Now this is kind of strange to try to read this, but let's see what it does. If I go Menu, Analyze, Intersect, now it's probably going to say, okay, there's too many things on here. Which things do you want me to intersect? Notice how it says graph down there. I want to use that one. And now what else? How about the blue one? And then again, it's going to ask lower and upper. So there's one there. I want to do it again. Analyze intersection, which graphs, the blue and the black, from there to there. And it's going to give me these 2 points. Now, these are hard to see because there's so much junk in the way, but they're in there. And dragging these things I know around on a real calculator is harder than it is. It's harder than it would be than it is on this computer. Anyway, there they are. It's the negative 2.48, right? Because this is the negative 2.330, so it's negative 2.48 something, and this negative is positive 1.39. I want to just grab those. So there you go. On a calculator, that's really pretty easy. On the doing that algebraically, that's kind of a pain in the butt. But get rid of this whole thing here. It doesn't make sense. But this is the only level of accuracy I'm gonna care about. Okay, number 2. Farmer wants to enclose an area of his property. He wants to use this much fence. Draw a diagram. All right, so I got a rectangle on there, and the dimensions are going to be, it says to use x as one of the dimensions, and if the whole thing has to have a perimeter of 120, then the length plus the width has to end up being half the perimeter. We've done this before. So the other side has to be 60 minus x. Sorry, that's so bad. Okay, so there we go. And then it says write a function for the area. I'll do that. It's going to be length times width. So area is simply going to be x times 60 minus x. Whoops, it's minus. Okay, give the plausible domain and range for this situation. Okay, so we could go ahead and try to graph this on the graphing calculator. We could just say, well, given this situation, like what's the smallest x could be? That's what domain is, right? What's the smallest x could be? What's the greatest x could be? And then range, so what's the smallest area could be? What's the greatest area? Let's look at the graph and let's see if we can make any sense of domain and range that way first. So like me, you probably have all this junk in your calculator right now and you don't want to mess with it. So I would go back to the home screen and let's just make a new document. I don't even care about this stuff anymore. If you do, you can save it and you can come back to it later. I don't want to save this. I want to make a new thing. I want to make it a graph. All right, and this is going to be x times 60 minus x. Let's graph that. Okay, that's all I see. Looks like a vertical line. That's pretty horrible. In this situation, sometimes zoom fit at least gets me some kind of reasonable scale. It's not quite as far right as I want to see, so let me zoom out once or twice and see if that gets me. And I want to see more of this, right? Because I think this thing looks like it's curving, and like eventually farther off the graph here, it's going to start turning down. If I zoom out that way, yeah, okay, good. Looks like that. And like, if you're like me, you like to see this box where you see the vertices and the vertex and the intercepts kind of fill in the screen. So I kind of like it about there. That's kind of nice. And the zoom box is always good once you have all this stuff. Okay, so what's a plausible domain and range for this thing? Well, it looks like it goes through 0, 0. Does that make sense? Does 0, 0 make sense on that graph? Well, yeah, if x is 0, remember x is the width and y is the area. So if the width is 0, yeah, it makes sense that the area is going to be 0, and x can then grow from there. We're going to start to get some area, and then as x gets bigger, area gets bigger for a while. Then after a while, it starts to come down until we get to this point out here, where eventually, if the width is big enough, this rectangle is going to smash down, and it's going to look so skinny that it's back down to being a 0 area. Let me see if I can draw that really quick. Here, see if this works. Yeah. So like this rectangle could be like, 60 by 0, which has 0 area, or I could start to add width. I got to take away from length as I do that because I have only a limited amount of fencing. And then at some point, the areas are going to be different all the way. Something like between here, and as I get shorter length, I can start to add some width. I'll start to get some area. at some point there's going to be some maximum area, but then at the end there's a limit to that, right? I can only